I would like you to be able to write a quadratic equation if all I give you are the solutions. So let's say that the solutions to the quadratic equation are 3 and -5. In other words, x equals 3 and -5. What would one possible quadratic equation look like that has these solutions? Well, this is how we do it. We're going to take the solutions and we're going to make them into factors. And the way we make them into factors is we kind of use the zero product property. We say, well, what would I do in order to get zeros here? So again, something times something, two things multiplied together, we call those factors, equals 0. 0 would be the product, so this is zero product property. So what could I do with x and 3 to make a 0? Well, it's minus, all right? And so if x was 3, then this would be 0, and so therefore this statement would be true. And on the other hand, if I put x plus 5 here, if x was -5, then this would be 0 and this statement would be true. So certainly, if I had these two guys as factors, this would be a quadratic equation that has these two as solutions. So let's go ahead and, but now we need to FOIL it out so that we can see what it looks like after it's all multiplied out. -3x plus 5x gets us plus 2x, and then minus 15. And then equals 0. And that is what we're looking for. When we say write the quadratic equation given the solutions, this is what we're looking for. That's the answer. So hopefully that's pretty straightforward. I would like to show you one that's a little bit more tricky. So let's see what you think of this. So this time the solutions are -2/3 and 1/7. Those are the two values for x if you solve a particular quadratic equation. So let's see how we could make the factors here. Again, we're going to have two things multiplied together and they will equal 0. And then in this case, what we could do really easily is just say x plus 2/3. And then x minus 1/7. That's just what I did just a minute ago, except I had whole numbers instead of fractions. The only thing is that that's not considered the final form. If you want to get the answer right on a test, we got to take this 3 and we have to slide it in front. We're going to actually slide it out in front of the x, and we'll take this 7 and we'll slide it out in front of that x, and when we do that, then we will have the correct form of the quadratic. So this will be 3x plus 2 times 7x minus 1, and that equals 0. And if you wanted to do the math and you set 3x plus 2 equal to 0, you'd see that that does equal x does equal -2/3. And if you set 7x minus 1 equal to 0 and solved, you'd see that x does equal 1/7. It's worth trying. If you're not sure what I'm talking about, try setting this equal to 0 and solve for x. Try setting this equal to 0 and solve for x. You do that, you will be a stronger math student. All right, so then we'll FOIL and finish this off. This will get us 21x squared, and then we do, let's see, 14x, 2 times 7, and then minus 3, so plus 11x, and then 2 times -1 minus 2 equals 0. And that's the final form of our answer. Now, one last thing that's kind of a neat idea is that we could check this. It turns out that if I change this 0 into a y, I could graph this guy as what's known as a quadratic function. And if I did the math correctly, and I graph this, what I should find is that the x-intercepts of this graph should be at -2/3 and positive 1/7. Ooh! For those of you that are daring, you can try that with Desmos. Go ahead and plug this in and see what happens. Oh, oops! Did make a little mistake. I know that one of you would have caught that, but I'm going to try to catch myself in advance here. So So let's see here. So anyways, if you took this 21x squared plus 11x minus 2, if I did the math correctly and you graph this, it should have an x-intercept at -2/3 and +1/7. Give it a try in Desmos. All right, that's it for this video.